All right, let's dive in. Today, we're going to talk about the journey of data science. And it really is a journey, right? It's all about how we take this just absolute chaos of raw information and turn it into something clear, something powerful, something that can actually help us see what's coming next. So, here's the game plan. First, we've got to talk about the raw material itself, data. Then, and this is a big one, we'll get into the great data cleanup. After that, the fun part, bringing it to life with visuals. Then we'll touch on how to predict the future with it. And we'll wrap up by looking at the cool tools that make all this magic happen. Okay, so first things first. Every single great project, I don't care what it is, starts with its raw materials. For a data scientist, that's not wood or steel. It's just information, plain and simple. Everything, absolutely everything, begins with the data. And you might be thinking, okay, data, I get it, but what is data, really? I know, it sounds like a super simple question, but trust me, how we answer this one, how we decide to define and categorize our information, well, that shapes every single thing we do later on. It's the foundation for the whole house. So, data basically comes in two main flavors. You've got your structured data. Think of a nice, neat spreadsheet. Everything's in its box, rows and columns, super organized. Computers love this stuff. But then, you've got the other side, the wild west of unstructured data. We're talking emails, videos, social media posts, text files. It's a total mess, right? But here's the secret. That's often where the real gold, the richest human insights are hiding. And just like a good detective, we also have to ask, where did this data come from? What's its origin story? Did we collect it ourselves, firsthand for a specific project? That's what we call primary data, like if you run a survey. Or did we find it? Is it secondary data, something someone else collected for a totally different reason that we can now use? Think government census data. Both are super, super valuable, just in different ways. Okay, so we've got our data. Now, you'd think the next step is to jump right into making cool charts and predictions, right? Wrong. And here's the big secret of data science, the thing nobody tells you at first. A huge chunk of a data scientist's time, maybe even most of it, is spent on the cleanup. So why bother? Why is this cleaning step so important? It all boils down to one simple, brutal truth. Garbage in, garbage out. I mean, think about it. If your foundation is cracked and messy, if your data has missing pieces or weird formatting, anything you build on top of it is going to be wobbly and unreliable. You just can't trust the results, period. So when we find those gaps, those missing pieces, you'll often see them called NA values. We can't just guess. No way. There's a process. First, you got to find them. Then you try to figure out why they're missing. Was it an error? Did someone just forget to fill it in? And once you have an idea, you have to make a choice. Do we just toss out that whole record, or can we use some smart statistical tricks to fill in the blank? It's a real judgment call. Another huge part of the cleanup is something called normalization. Let me give you an example. Imagine you're analyzing houses. You've got the price, which is in the hundreds of thousands of dollars, and you've got the number of bedrooms, which is like 3 or 4. If you just throw those numbers into a model, the giant house price number is going to completely overshadow the tiny bedroom number. It's not a fair fight. So normalization is like being a referee. It rescales everything to a standard range, usually between 0 and 1, so every feature gets a fair shake. All right, so our data is now clean, it's reliable, it's ready to go. Now comes my favorite part. This is where we stop looking at boring rows of numbers and we actually get to see our data. We're going to bring it to life and turn it into a story that our brains can actually understand. And believe me, we have a whole box of tools for this. You got scatter plots, which are awesome for seeing if two things are related. Like does one go up when the other goes up? Then you have heat maps, which use color to show you where the action is. They literally show you the hot spots in your data. It's so cool. Every type of chart tells a different kind of story. But one of the most useful, I think, is the box plot. It's like a Swiss Army knife for data visualization. In one little graphic, it gives you a full summary of your data. The middle point, the typical range, all of it. And, crucially, its main job is to scream at you when it finds an outlier, a data point that's way, way different from everything else. Okay, to really get this, just look at this simple string of numbers on the screen. Take a second. Can you spot the one that just doesn't quite belong? Yeah, you probably spotted it if you looked close enough. But a box plot? It would make the number 13 practically jump off the page in bright red. It flags it immediately and says, hey, look at me, I'm weird. That right there, that's the power of visualization. So, once we've cleaned the data and we've visualized it to understand the patterns of the past, we get to do something really exciting. We get to take the next big leap, using those patterns to try and predict the future. And this, my friends, is where we step into the incredible world of machine learning. A really common place to start is with something called supervised learning. And the name is perfect because it's like we're a teacher supervising a student. We give the computer a whole bunch of data that's already labeled with the right answers. It's just like giving it a stack of flashcards. The computer studies them over and over until it learns the patterns. And usually, this kind of learning is trying to do one of two things. First, there is classification. That's all about putting things into buckets or categories. Answering questions like, is this email spam or not spam? The second thing is regression. That's when you're trying to predict an actual number, like how much is this house going to sell for? So it's either putting it in a box or putting a number on it. Most predictions fall into one of those two. But what if you don't have flashcards? What if your data has no labels at all? Well, that's where unsupervised learning gets really interesting. With a technique like k-means clustering, you basically just hand the computer a giant pile of data and say, hey, I don't know what's in here. Find the natural groups for me. It's an amazing way to discover structures and patterns you never even knew to look for. Okay, last section. We've talked about the what and the why, but none of this incredible stuff would be possible without the right tools. We're talking massive amounts of data here. So let's take a quick look at the technology, the actual programming languages and databases that make all this work. One of the absolute cornerstones in any data scientist's toolkit is the programming language R. What's so cool about R is that it was literally built by people who do statistics for people who do statistics. So it has amazing, ready-to-go packages for basically every single step we've just talked about, from the cleaning all the way to the fancy visualizations. It's a beast. And it's not just the analysis tools that have changed. The way we store data has had a total revolution. We used to rely on these traditional relational databases, right? Think of them like super strict, rigid spreadsheets. But now we've moved to what are called NoSQL databases. And these new systems were built from the ground up to handle the exact kind of massive, messy, unstructured data that the modern internet pumps out every second. And that's their superpower, really. Take a database like MongoDB, a big name in the NoSQL world. It's incredibly flexible. It doesn't freak out if your data doesn't fit into a perfect little box. And it's designed to grow, to scale out across tons of computers. It's just perfectly built for the fire hose of data we have to deal with today. So look, if you take away just one thing from all this, let it be this. Data science isn't a single magic trick. It's a process. It's a journey. It's this really deliberate path we take from that initial mountain of chaos all the way to clean, useful insights that, can actually give us a little glimpse into what's coming next. And that really is the most exciting part, isn't it? Every time you click something, every purchase you make, every little bit of information being created is part of some bigger story, which leaves you with a pretty cool question to think about. If all that data is telling a story, what story is the data all around you just waiting to tell?